Hello everyone, it's Edu. I want to share something with you guys that I think is really cool, but I don't want to have to write all of it, so I'm just going to film it, and you guys are going to indulge my inner nerd and 19th century naturalist person, and you're going to have to excuse the noise around me because there's construction going on around me always, and the birds are going a little bit crazy. So this is about a flower that I think is super cool. So the flower is growing right next to my place, and I found it just walking outside during the summer, and I had not stopped to just appreciate what's around me. But I found it, and it's called Love in the Mist, which is a really pretty name. I had to identify it. I'm pretty sure that's the species. And they make this, so the flowers, after they're fertilized, they make this really interesting sort of otherworldly seed pod. So it's right here. And you can see like the symmetry around it. So this one has 1, 2, 3, 4, 5, 6, 7 sections to the pod. And when you open the pods, they make like the most, what I can only describe as like the most satisfying and hollow crunch sound. And they're riddled with seeds inside. This one, all the seeds already fell out. But if I opened it, they would have seeds all over the pod. I might open this one later. But the coolest thing about the flower that I found is looking a little bit more closely. Let me find a good example of it. Here's one. So if you notice, the pistil, which is the female part of the plant, is in the center and it's in green, has these projections that start curling down. They always start curling down. They curl down right towards the anthers, which is the male part of the plant in yellow that has all the sperm. And normally, the flower just relies on pollinators to come in contact with the pollen and then brush up against the opening of the pistil and fertilize the plant. But this one just evolved a strategy to just like make these projections out of the pistil, that's P-I-S-T-I-L, and just elongate them and curl them down right to come in contact with the anther, which is a really smart strategy. And I had never seen it before. Maybe I'm just like stupid and I didn't know that this was a thing. And the molecular mechanism behind it is probably that there is asymmetric cell division. So on the top of the projections, you would have more cell division and more cells sort of cramming up against each other, whereas in the bottom of the projection, you have slower cell division. So it could be cell division, or it could be just uptake of water. So you could take water asymmetrically, so more water at the top, less water at the bottom, and that creates pressure, and then the little projections just move downward. But then once the plant is fertilized, so there's a good example around here. Where is it? Oh, here's one. So once the pistil has been received the sperm, so the little projections just like stretch out outward, and then the pod begins to grow. So then here is an example of a very young little pod, right? So you can tell it's just the pistil has just started to gorge up and grow up, keeping the seeds inside. There's another stage, and then they're super big. And you can see that the projections are still there, but they've started to sort of wither away at the tips. Let me see if I can focus this. Anyway, you got it. So let me see if I can open one of these. Sorry, I'm gonna have to kill you. Okay. Hold on a second. So here's one of the pods cracked open, and it's absolutely beautiful. All the seeds just lined up along the center of the pod. This one had, I think, 7 sections. You can open up each section individually, and they all make this really awesome cracking sound that I can't show you because I need both hands to do it. But yeah, Love in the Mist. It's really cool. A really pretty flower.
Bye.